Yesterday we worked on the basics of right triangle trigonometry, and we practiced labeling the sides of a right triangle. And we also practiced how to set up the problem by setting up what is called trigonometric ratios. So now, today, you're going to learn why we learned that. Okay, so today we'll actually start learning how to actually solve one of these triangles. And in other words, today we're going to practice how to find a side of the triangle. Tomorrow we'll practice how to use what we learned to find the angle of these triangles. All right. And so a lot of the stuff that we did yesterday will actually transfer very easily to what we do today. Okay. But this time, after we actually get the problem set up, we're actually going to take it the next step and we're going to solve it. Okay. And so it's not going to be a huge difference, but because we're actually solving, you'll find out that there are a couple of things that will be a little bit different than what we talked about yesterday. All right. So today, like I said, is we are going to use the right triangle trigonometry to find the side of these triangles. All right. So before we actually get into the problem, I'm going to run through the steps, and some of them may not make total sense right now until we actually get going with an example. But I just want you to kind of run through just the basic steps. All right. And so whenever you actually have to solve for the side or an angle in these triangles, the first thing that you actually want to do is set your calculator in degrees. All right. And so, because I know a lot of you may not have the calculators that we've been using in class, I'm going to actually show you on the calculator, but I'm also going to show you how you can use the Desmos app on your phone or on your computer to find it as well. Okay. And so, or to set it in degrees. All right. So if you have a calculator like the TI-83 or TI-84, to set it in degree mode, you're going to go to, you're going to hit the mode button, which is right beside the second button, and it's going to bring up a whole mess of stuff. So let me see if I can get it to where you can see it. I don't know if you can see it very well, but if it'll, maybe if I zoom in a bit. Yes, there we go. So if you look, it brings up a whole craziness of stuff. But if you go down here, you'll see radian and degree. For these problems, all of the angles are in degrees. And so you want to set it and you want to highlight the degree and then press enter. And your calculator will be set to work with degrees. Okay. Now, if you don't have a calculator like that, you can use the Desmos app. So I will pull up the Desmos app on my phone real quick. And so if you have Desmos, then to set your calculator for Desmos, then you hit the little wrench that's in the upper right corner on your graph, and you'll see at the bottom it'll say radians or degrees. And you just hit the degrees, and voila, it will be in degrees for you. Okay. If you forget to do this, your answers will all be wrong. And so definitely want to try to make sure that you remember to do that before you start any of these right triangle trig problems. All right. So once you do that, the next step to being able to set it up so that you can find the side of a triangle is you want to figure out which angle. If you remember yesterday, I talked about you want to act like you're standing at the angle. So you're going to figure out which angle you're supposed to be standing at. And we'll talk about that whenever we actually get to an example. Then, just like what we did yesterday, you label your sides. One of them will be the hypotenuse. One of them will be the opposite side, and then the other one will be the adjacent. Then you've got to actually figure out with these problems which function you're supposed to be using. So you can use, it'll be either the sine, cosine, or the tangent function. And then you set it up, which is what we did with the trigonometric ratios. And then you solve. Okay. And so those are the steps. So let's actually run through a problem so that you can see how it works. All right. So we've already got our calculator or our Desmos app set in degrees. So then the next step is you want to figure out where you're standing. And so notice these problems, like for instance, number one, you're finding x. So x is the length of this side. So notice you're finding a side, okay? And then you're given other information. So this is the reason why these problems are a little different, is because you're actually going to be given some information and you have to use that information to find a side, all right? And so to figure out where you're standing, it's going to be an angle. And so it's either going to be the angle that you're given, so the angle you are given, or if you're having to find an angle, like the problems we do tomorrow, you'll stand at the angle you're finding. So it's the angle you are given or the angle you have to find. Let's see if I can squeeze that in there. All right. So in this problem, if you look, remember you never stand at the 90-degree angle, so make sure you don't stand there. But if you look at the other angles, the other angle we're given is this 55 degrees. So that's actually the angle you're going to stand at. So again, you can put a little dot right there and act like you're standing there. Or if you use the arches from what we did yesterday, you can put a little arch in that angle to know that you're standing there. All right. So from there, you label your sides just like you did yesterday. So remember, you've got the hypotenuse, the opposite, and the adjacent. All right. So the hypotenuse is the one across from that 90. So this one right here would be your hypotenuse. The opposite is the side that's opposite of the angle that you're standing at. So if you're standing right here, the side that's opposite of where you're standing would be over here. And remember, it's also the side that that angle does not touch. So if you're standing here, that would be the opposite side. And then the adjacent side is the side that's beside you, but it's not your hypotenuse. All right. So we labeled our sides. The next part, which this is a little bit different than what we did yesterday, because yesterday you were actually told where which functions you were using, all right? But now you have to actually figure out which function do I need to use to be able to find that side. And so it'll actually kind of be a little obvious to you for most problems because you're going to notice that in these problems, notice you have to find that side, you're given that side, and then you don't have anything going on with the other side. So most of the time, the function that you use, you're going to have to start by getting rid of one of your sides, all right? And so to do that, look at the one that you do not have to find and the side that you don't have any information about. That's the one you get rid of. And so notice, because we have to find this side, and we know something about this side, this one would be the one that we don't need because we don't have to find it and we're not given information about it. So you actually get rid of a side, and it's the side that you don't know anything about and you're not having to find, all right? So that's where you start. So get rid of a side. And then look at the sides that are left, okay? And look at the sides left over. That's actually going to clue you in as to which function. Now, the other thing that you have to remember is that way of remembering the trig. So think back to yesterday. Did you remember it by the acronym, the word, or did you remember it by the sentence? Okay. And so because I did more with the word yesterday, I'm going to write the word. So remember, the word is so, toa. And that actually helps you remember what goes with what. So like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. And so looking at the sides that we did not cross out, we are left with opposite and adjacent. So think about these three functions and look at which one deals with both opposite and adjacent. If you look, that one, which is the tangent function, deals with both opposite and adjacent. So that's the function we're going to use. So because that's the one that deals with both of these. We're going to write down tangent, and then we're going to set up our problem. Okay, so this was what we did yesterday with the trig ratios. We practiced setting up that problem. All right, so it's the tangent, remember, of your angle. So now we actually have an angle there. So you put the tangent and then you put the angle that you're standing at. So it'd be the tangent of 55 equals, and then tangent is opposite over adjacent. So you put equals the opposite over the adjacent. And then from there, you just have to solve. So in other words, you're trying to get the x by itself. So think about this, which is a lot of times, sometimes hard for people. But the tangent in the 55, this is not tangent times 55. This is tangent of 55. So you need to think of this like a number because it really is just going to be a number, okay? And so if you're thinking of this like a number, this is like a number equals x over 4. Well, to get x by itself, you're going to have to get this 4 away. So to solve, you just simply do the opposite. So instead of dividing by 4, we're going to multiply by 4. And then remember, what we do to one side, we have to do to the other side. So remember, this goes together. So what you actually do is you bring that 4 and you bring it to the front of that, okay? So this will be the same thing as like 4 times whatever this number is, all right? And then these will go away. And then you'll be left with x equals whatever 4 times the tangent of 55 is, all right? Now, if you do not have a calculator at home, or you do not have like a computer or anything like that, where you can type this in, you can use the Desmos app or whatever, then you are more than welcome to leave your answers like this, where all you would have to do is just type it in once you got a calculator. And so this is one way that you will be able to write your answers for the homework. Or if you actually have a calculator, you might as well practice. Or if you have the Desmos app, which most of you probably, if you have something to do it with, probably have that. I'm going to show you how to type this in Desmos. All right, so let me see if I can let it focus a little bit. So if you're typing that in Desmos, you would type in 4. And then if you look right here, it says functions, and it'll bring up all the functions. And we were using the tangent, so you type in tangent, and then you type in your angle, 55. And then again, make sure that your Desmos app is set to work with degrees, and it will give you the answer. So your answer will end up being 5.71. All right. And so that is actually the length of that side. And so notice the lengths of the sides were in centimeters. So that side has a length of 5.71 centimeters. All right. So that is how you set it up and how you actually solve. All right. So let's do another one. All right. So this one, we have to find the length of this side. All right. Well, first step, we already have our calculator in degrees, so we're good there. Figure out where you're standing. Remember, you're going to stand at either the angle that you're given or the angle you have to find. So if you look at this triangle, the angle that we're given is the 37 degrees. So we're going to stand there. And then you're going to label your sides. All right. And again, you can put a little arch if you want to do that. The side that's opposite of the 90-degree angle is your hypotenuse. The side that's opposite of where you're standing, which would be this side right here, is your opposite. And then the side that's beside you, beside where you're standing, but not the hypotenuse, is your adjacent. Okay, so we labeled our sides. The next thing is we have to figure out the function. So remember, you got to get rid of a side, and then you look at the sides left over. So the side that you don't need here, well, remember, it's the side that you're not trying to find and the side that you don't really have any information about. So which one do we not really care about here? Well, notice the opposite has nothing going on for it. We don't need it. We don't have to find it. So you get rid of it. And then you look at what's left. We're left with the adjacent and the hypotenuse. So if we write our handy dandy word down, SOHCAHTOA, which function deals with both adjacent and hypotenuse? Well, if you look, the cosine has both the adjacent and the hypotenuse with it. So that means we use the cosine function. So it's, remember, the cosine of your angle. Don't forget, it's of your angle. Those go together. And then make sure you put your equals. And then you have to remember cosine is adjacent over hypotenuse. So cosine would be 3 over the hypotenuse is x. All right. So we just set up our trig ratio. And now we have to solve. So this one's a little different than the one we did before, because with the one we did before, you had the 4 on the bottom. So you just had to multiply by 4 to get it off. Now you have the x on the bottom. All right. So there's 2 ways to do this problem. All right. One way is to use what you know about proportions, which I'll explain that in a second. The other way is you could kind of start this problem how you did the other one. Because you have the x on the bottom, you actually would have to multiply by x on both sides to get the x off the bottom. And then you'd have x times the cosine of 37 on this side. Remember, you can't separate those. Those go together. And then on this side, it'd have equal 3. And then from there, to get the x by itself, remember, this is one number here. So since you're multiplying by that, you would actually think of it like a number. You would divide by that number on both sides. Okay. And then your x, because those will go away because it's the same thing on the top and the bottom of a fraction. That means that your x would be by itself and it would equal whatever 3 over the cosine of 37 is. All right. And again, if you do not have a calculator or a way to type this in to figure out what this is actually equal to, you are more than welcome to leave it like that. Just make sure that your x is by itself. Okay. Or if you do actually have a calculator you can do it with, you can just type it in. Okay. So let's go ahead and type that in. Let me pull up my Desmos app again, and we'll probably have to zoom in again. Oh man, that's not so bad. So let me exit out of the one I just did. So this time we're typing in 3 divided by, and then you'll type in your function. So it's the cosine of 37. And then if you want to close your parentheses, you can, and then there's your answer. So x would equal 3.7, and if we round to the nearest hundredth, that's 6, we'll round the 5 up. And so it's 3.76. And then the units, because it's the length of this side, and if I look, the units for this is in inches. We got inches. All right. So that is the answer to that problem. All right. Now, the other way that I was talking about, so I'm going to go back up here and I'm going to rewrite how we had this thing set up. Okay. There is another way to kind of make it so you don't have to do so many steps when you're solving. And there is a little trick you can use with what we learned about proportions way back in the day. All right. Remember, I said this is like a number. Okay. So every number is understood to be over a 1. Well, if you think about in proportion land, you usually cross multiply whenever you have a fraction equal to a fraction. So if you kind of use that principle, technically we'd be multiplying these two and multiplying those. Thinking about that, multiplication, you can flip around the numbers. And so a trick you could use here, if you wanted to try to make it so you didn't have to do so many steps, is you could actually flip-flop these two, and it'll be perfectly legal because of what we talked about with proportions. And it'll actually make your life easier because notice the x will come on top of the 1, and then that cosine of 37 will go to the bottom over here. And x over 1 is just x. So that technically means that x would actually be by itself now. And notice you have in one step did what we did in a couple steps here. And so if you realize that it's one of those problems, like if you have the x on the bottom of a fraction, you could do that little flip around trick and it'll make it to where the x is by itself. And then you can just type it in just like what we did and you'll get the same answer. Okay. And so you can choose whichever way you want to do it, but I just thought I'd show you the trick. All right, let's do one more problem and then we will call it a day. All right, so notice in this problem, we have to actually find both sides of this triangle. All right, you're going to start it out the same exact way. So figure out where you're standing. It's the angle that you're given or the angle you have to find, which notice we're given the 50-degree angle. Remember, you never stand at the 90-degree angle. So I'm going to put a little arch right there. Then we label our sides. All right, so the one across from the 90 is hypotenuse. The one across from where you're standing is the opposite, and then the one beside you, but not the hypotenuse, is your adjacent. Okay, and so notice with this one, it is a little different because whenever we have to find which function we are using, we actually have stuff with every single side. So this is actually where you have to do one thing at a time, all right? So since we have to find both x and y, I'm going to start by just finding one of my letters first, or one of my sides. So I'm going to start with finding x. So I'm going to kind of ignore y right now, all right? So I'm going to kind of act like it doesn't exist just for a second, and then I'm going to do it with the x. So that means in this problem that I don't need my adjacent because I'm not trying to find it and I don't know anything about it, all right? So then I'm left with opposite and hypotenuse. So think about the SOHCAHTOA. Which one deals with both opposite and hypotenuse? That would be my sine. So it would be the sine of your angle, which is 50, equals opposite over hypotenuse. So it'd be x over 15. And then I solve. So I have the 15 on the bottom. So to get the x by itself, I have to multiply by 15 on both sides. All right, so when I multiply by 15, those go away. And x would equal whatever 15 times the sine of 50 is. So again, you can leave your answer like that, or you can type it in. And so if I type it in, and type it in real quick, 15 sine of 50, we get 11.49. Okay, so there's x, and my units are meters. So I'm going to put meters. All right, now I've found x. So now I'm going to go back to my problem and I'm going to start looking back at y. All right, so now that I've found x, guess what I'm going to do with this side? I'm going to ignore this one. So I'm going to kind of just ignore it. And now I'm going to look at what's left. So that means because I'm ignoring this one, I ignore the opposite side and I look at what's left. All right, so zoom out just a bit. If I think about my SOHCAHTOA again, you kind of have to backtrack because you got different sides now. Which one deals with both adjacent and hypotenuse? Well, that would be the cosine. So it'd be the cosine of your angle, which is 50, equals adjacent over hypotenuse. So adjacent is y over the hypotenuse is 15. And then to solve for y, to get the y by itself, I'm dividing it by 15. So the opposite would be to multiply by 15 on both sides. So then those go away. And y would equal whatever 15 cosine of 50 is. And again, if you don't have a calculator, you can leave it like that. Or you can type that in. So I'll type that in real quick. 15 cosine of 50. We get 9.64. And then again, that's the length of this side, and the units are meters, so it'd be 9.64 meters. All right. Hopefully this helps. Have a wonderful day.